Hello! This week should be a pretty relatively simple and quick week. I decided to chop 8th grade investigations of patterns and bivariate data into 2 weeks, 2 sections. So this week we're just going to focus on the first 2 of the standards. And so those are Standard 1, construct and interpret scatter plots for bivariate measurement of data to investigate patterns of association between 2 quantities, and describe those patterns such as clustering, outliers, positive or negative association, linear association, and nonlinear association. So we'll look at some CPM lessons. I don't know if you guys can tell, CPM is actually my favorite of all the curricula that I've worked with before, so I gravitate to it quite frequently. Number 2, know that straight lines are widely used to model relationships between 2 quantities, between 2 quantitative variables. So, for example, if something is increasing, that causes another thing to increase as well, and that would be a positive association. For example, if shoe size were if height of a child is increasing, then their shoe size typically increases as well. So there's that kind of association. And just as an example, for scatter plots that suggest a linear association, informally fit a straight line and informally assess the model fit by judging the closeness of the data points to the line. So students in 8th grade are introduced to this idea of finding a best fit line, and it's very informal, just sort of guessing what's going to be best, and informally judging the closeness of the data points as well. So I'd like to talk a little bit in this quick video about what that looks like more formally. In fact, I've attached a second video that I found on YouTube that I like. It describes really nicely that idea. So first, let's take a quick look at the vocabulary that is mentioned in Standard 1. So here we have a description of line of best fit. So that's a line going through the center of a group of data points that tend towards a linear pattern. So you can tell students if it behaves like a line, if it looks line-like, line-ish, then it can be modeled with a line, and we sort of do our best to draw a line through the data points. And so it's a useful thing to show students some good examples of a line of best fit and some bad examples. Perhaps change the slope of that line to show that it doesn't nicely go through that. It does not nicely create a trend line. Now, as you move forward further in mathematics, they start talking about finding an exact equation, and we're going to look at finding an equation next week of our line of best fit using our slope and intercept values. But you might have heard of regression line, or of something called least squares regression, and that is a method for calculating the exact best line, the exact slope and intercept and equation of the best line possible. So that YouTube video that I posted after this one describes that, and I really liked the explanation. So you're not going to need to learn the mathematics, but it's a really good explanation of the idea of how of what it means and what's being thought about when it's being calculated. Okay, so some more vocabulary that is introduced and strengthened for 8th grade students is positive and negative association. So this first graph here shows a negative association. As something increases on the x-axis, it is decreasing on the y-axis. An example of a negative association is the value of a car decreasing as its mileage on the odometer increases. That's a negative association. And then here we've got a another negative association. We've got a positive association here. Something along the x-axis is increasing as along the y-axis is also increasing. So this goes along with that example I shared with height increasing, shoe size increasing. Then we have some descriptions of the strength of association. So the first one is very, very close to linear, and so it's considered a strong association. And then we've got a medium or a moderate association here in the center, and then a weak association, just barely increasing, but a lot more scattered. So very, very scattered data would just be considered no association. Then we've got nonlinear associations. Down here at the bottom, we've got an example of a nonlinear association. In fact, if a regression was performed here, it might be more parabolic or exponential because it is not straight but curved. And then something that is obviously not part of a trend would be considered an outlier. And there would be a mathematical definition of what makes something an outlier, but you do not go into that in 8th grade. So I think that is about it for the vocabulary associated with the first 2 standards. For your assignment this week, you'll be reading a CPM lesson and reflecting on it. Just share what stands out to you. What do you like? What do you dislike? What would you change? Anything that you'd like to mention. I wanted to leave it very, very open. And it's been a busy semester, I'm sure. I want this week to be pretty quick and painless for you. The assignment is another assignment from this same section where you will take a look at a series of questions that a class might go through, introducing them to making a scatter plot and using what they see to perhaps extrapolate a potential piece of data. And so you will have one problem to do. You're going to take a set of data and do one scatter plot and then describe whether you think the roller coaster described in the problem is safe or not. And that's pretty much for the week. So I hope you have a good one, and I will talk with you next week. Thanks. Bye.